Hi everybody, this is Miss Apple again. Today we will talk about something very interesting. Quantum dot displays, QLED, a comprehensive overview. Quantum dot displays, commonly marked as QLED, quantum dot light emitting diode, represent a pivotal advancement in display technology, leveraging nanoscale semiconductor particles called quantum dots. QDs to achieve superior color accuracy, brightness, and efficiency, while QLED is often a branded term popularized by Samsung. The core technology enhances LCD, OLED, and emerging micro LED panels. Below, I'll cover the history, underlying science, how it works, advantages, and future prospects, drawing on key milestones up to November 2025. Woo! Brief history of quantum dot displays. Quantum dots were first conceptualized in the 1980s, but their application in displays evolved rapidly from lab experiments to commercial products. Here is a timeline of major developments. 1980, the year 1980, milestone. Independent discovery of QDs by Alexei Ekimov, Soviet Union, and Louis Bruce, Bell Labs. Foundational work on size tunable emission. Key players impact laid groundwork for semiconductor nanocrystals. No display use yet. 1990s, woof, woof, 1990s to 2000s. Early research on QD electroluminescence, QDs explored in solar cells. Key players, academic focus, Mark Reed coins quantum dot term, 1988. 2013, Sony launches first commercial QD enhanced LCD TV, Triluminous, 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 using QD films for backlighting. The key players marked entry into consumer market, improved color gamut over standard LEDs. 2014, Samsung develops cadmium-free QDs, integrates into SUHD TVs, address toxicity concerns, boosted eco-friendliness. 2015, CES showcase by Samsung, TCL, and Sony QD enhanced LED backlit LCDs go mainstream. Keywords widespread adoption. TVs achieve over 100% DCI-P3 color coverage. 2017, Samsung rebrands SUHD as QLED, forms QLED alliance with Hisense and TCL. Keywords. QLED becomes synonymous with premium QD TVs, focuses on higher brightness up to 2000 nits. 2019-2020, Samsung achieves red QD emitters, develops blue QLED prototypes, luminous efficiency over 20%. Keywords pave way for self-emissive QLEDs. Blue remains challenging due to efficiency gaps. Parentheses. Blue is always like the color that provides like a challenge to humanity. In the previous video, I spoke of the history of color, and blue, in the beginning of history, blue was even more expensive than gold. And now, in the quantum era that we're living in, blue remains challenging to efficiency gaps in this context. Okay, closing parentheses. 2022, Samsung achieves red. Uh, 2022, Samsung launches QD-OD LED TVs. For instance, S95B, first commercial hybrid QD plus OLED panels. One CES Best of Innovation combines QD color with OLED contrast. Then on the year 2023-2024, QD color converters, QDCC, commercialized for OLED, micro-LED, perovskite, perovskite QDs, MPQD, gain traction for cost-effective alternatives. Keywords offer high quantum yield, over 90%. Then 2025, as of November 2025, advances in QD on glass for cost reduction, blue self-emissive QLEDs reach 20.2% efficiency. Samsung's Neo um, models dominate, market projected at $550 million for QD materials by 2034. Okay, so the main character here is Samsung and its technology in quantum efficiency. Keywords focus on how automotive displays in cadmium-free PQDs, AI optimized QD design emerge. So artificial intelligence is assisting on the design. Woo! Okay. The technology's commercialization exploded post 2013, driven by Samsung's R&D via Samsung Advanced Institute of Technology in partnership with like Nanosys QD film supplier. By 2025, QD Tech is in 30% of premium TVs with annual shipments exceeding 10 million units. How quantum dot displays work? Now, this is what I really want to know about. How does it work? How do quantum little dots display work? QDs are tiny semiconductor nanocrystals from 2 to 10 nanomillimeters in diameter, made from materials like cadmium selenide, indium phosphide, or perovskite. Their magic lies in the quantum confinement effect. Their magic lays in the quantum confinement effect. Electrons are trapped in a confined space, causing their energy levels to depend on particle size. Smaller dots emit blue light, larger ones red. Small blue, larger red. This enables precise tunable emission. Core mechanisms: QEDs absorb light from a black light to oxidation source and re-emit it at specific wavelengths with narrow spectral line widths, 20 to 30 nanometers, producing pure colors without overlap. Ah. In photoemissive QLED, most common today, QEDs act as color converters in LCD backlights. Blue LEDs excite red, green, QD layers creating full RGB without traditional filters. In electroemissive QLED emerging, QEDs emit light directly when voltage is applied, like LED but inorganic. Each pixel itself emits, eliminating black lights for thinner, faster panels. QD-OLED hybrid. Blue OLED excites QD layers for red-green, achieving near infinite contrast with QD vibrancy. Key components: QD film enhancement film, QDEF, thin layer between backlight and LCD, QD color filter, pattern QDs on panels for pixel level control, excitation source, typically blue LEDs for efficiency, UV or green LEDs in prototypes. This results in 135% approximately sRGB coverage, far surpassing standard LCDs of approximately 70%. So everything with quantum energy becomes advantages on QLED over other technologies. QLED shines in bright environments and large screens, making it ideal for HDR content. Movies! Applications and market impact. Consumer TVs, monitors, and commercials. Emerging large I repeat, ultra large screens. Medical imaging for precise color rendering. Market $2.5 billion in 2025 displays. Projected $10 billion by 2030. driven by 8K AR VR integration. Future prospects. By 2030, self-emissive QLEDs could replace OLED in 40% of high-end TVs with peroxide QDs, slashing costs 50% and enabling flexible wearable displays. Challenges like cadmium toxicity are mitigated via NP alternatives and AI optimized QDs promise adaptive colors. Okay, okay. QLED isn't a replacement for OLED, but uh, an, an enhancer, pushing displays toward human eye-like fidelity. Very interesting. I like to learn about quantum physics and art. See you next time.